exciting world of these virtual training. You could be getting a haircut and doing safe system assessments all at once.
And counting your wallies.
Yes.
Good.
And talking to the hairdresser about biomechanics of injury.
Even better. Let's do it. Is that what we're doing today?
Well, we are going to delve into that.
Great.
We had a great discussion with this group last session around that sort of safe system philosophy. We started honing it into the infrastructure side of things. We looked a bit about sort of general road safety, behavioral things, enforcement, the like. And we talked about vehicles and ANCAP and those sort of things. But this one we delve into what we spend more of our time doing, well, this group does, is the road environment, the speed, and so those sort of things. So we're going to get into it when we're recording, of course. The kinetic energy thresholds for different crash types, which we discussed. We started with the Usain Bolt analogy, which many are familiar with, and then we went in a little bit further looking at different crash types. We're going to use that. We're going to dig further into that, and we're going to try and understand how we might make some assessments based on that. And we'll do that for intersections, and we'll do it for mid-block locations as well. So we'll really find out what aligns highly in the built environment for intersections and mid-blocks for safe system principles. Don't forget to count your wallies, of course. Okay, so intersections, really, interesting, fascinating point on the road network, and they are a point of increased risk, elevated risk at intersections. Now, that's for a number of reasons. One, of course, is that we have conflict points. So you can see here our little picture, and we've got vehicles crashing. Of course, that's what a lot of people think about as an intersection crash. And certainly it is an intersection crash. Okay, but we also have pedestrians are going to need to be crossing roads at this location. So we've got that conflict. We've got cyclists that'll be crossing and involved in those conflict points, motorcyclists as well. We also have an increased sort of run-off road likelihood at these locations. And why is that? Well, that's because people will avoid or clip vehicles before they crash. And so we have this sort of increased turbulence at these areas of the road network. So people leaving the road to avoid that crash or avoid things here and there. And we also have a lot of fixed hazards around intersections. So in this one, you can see a signal pedestal, fixed hazard, but we'll also often have power poles at intersections because we need the power line to turn, essentially. So you've got to have a pole there. Often culverts at intersections because of drainage reasons. So we're seeing a lot of hazards in the roadsides at intersections. So what we tend to see, if you do a little thing we sort of call a risk worm, and I'll just use this bit here. So you've sort of got risk, and if you take, chainage along here, along a route, this way, you sort of will see, risk sort of bubbles along and then spikes and bubbles along and then spikes a bit there and then spikes again and then spikes. And those will be your intersections, all right? There's a just mid-block inherent risk, and then it sort of goes up and down. And so Monash University Accident Research Centre at one point sort of tried to say, well, what are some high-level principles for good intersection design that aligns with safe system principles? And I think it's worth sort of thinking about this very high-level stuff first before we delve into some really specific detail. But they started out there with fewer vehicles and fewer intersections. Now, if we think about what we ended last session with, which was exposure times likelihood times severity or consequence, is sort of risk, if you take that. These two are associated with the exposure to crashes. So either, if you eliminate an intersection, you've eliminated the exposure at that location. Now, yes, okay, we might have the vehicles go to another intersection. So you may increase exposure at another intersection, but at that particular one, we've sort of eliminated that exposure. And fewer vehicles is fewer exposure under this exposure likelihood severity thinking. Fewer conflict points per intersection. Now we're into likelihood. So a conflict point is just a way that you can crash. And I'll show a conflict point diagram. Some of you will know conflict point diagrams, intimately, but it's just less possible ways to crash. That often people want to bring this in as an exposure reduction in a safe system assessment, but we put it to a likelihood reduction. I'll explain sort of why that is later. Then we're into these sort of impact speeds and angles for passenger vehicles, trying to get them inside those biomechanically tolerable levels. And so these ones, again, are in these generic ones of 90-degree crashes, 50 kilometers per hour or below. You can get a bit more angle on that. So remember your year 11 vectors, sort of if you've got a crash that happens like that, only a small bit amount of the energy goes into the environment. But if you crash like that, you push more energy into the environment, sort of bounce off a bit. So if we can get a bit more angle on our crashes, so we can go somewhere between 50 and 70 kilometer per hour crashes within our tolerable levels. Pedestrians and cyclists, with thinking about them, we're into the 30 kilometer per hour or below. And if we can't be reaching these, we need to sort of reevaluate how we're operating that area and see if we can make some fundamental changes. Last session, I was showing quite a few of these impact speeds and angles for passenger vehicles mainly. And then we talk a little bit about pedestrian cyclists and got some sort of newer motorcycle data in there as well. So I won't spend too much time on that. But when you're doing a safe system assessment, you're going to be sort of thinking about the angles of crash. Now, you don't need to be this precise, although your designers can easily spit out an angle if you want. But for this, I'd be saying, okay, new intersections coming. Let's have a think about the angles. And I go, okay, a vehicle coming out here, being struck by a vehicle here, that's close enough to a right angle. So then I'd be thinking, well, what speed are we hoping that should be? We're thinking, 50 kilometers per hour or below. And they come out here. Okay, what about over here? And I'll say, oh, that angle, they've got more on it. I'd be more inclined to be thinking around the 60 kilometer per hour or below for that side would probably be, within our general safe system tolerances. So there are quite sophisticated tools reasonably sophisticated tools you can use. There's one called XChemX, the kinetic energy management model, but that's far beyond what you would ever need to do for a safe system assessment. Okay, if you're doing some sort of very in-depth study of an intersection and forces and the like, you might dig out some of those tools to use. But generally, because a safe system assessment is that risk assessment methodology, it's sort of broad brushish, you can simply make a judgment call on this based on that's the angle, that's the speed, that's what we know from the science, and generally this is where we're going. We also want to think about the secondary crashes, and that I alluded to that with those runoff road crash increases around intersections. So you have these vehicles avoiding crashes and running off the road. You have the two vehicles colliding and then they both leave the road, and you have secondary crashes. So thinking about about both of those. The Centre for Automotive Safety Research out of the University of Adelaide did some research on this. It's one of those ones where, you know, they did this big research report and you're like, pretty obvious, but that's all right. When you replot, you know, vehicle to vehicle crashes at intersections, the secondary crashes come out in these areas. There's a few interesting ones, you know, clip offs and avoiding and weird bits and pieces like that. But they're where the secondary death and serious injury are occurring in those crash locations. So Kathy, I reckon that's enough talking out of me. Well, I'm going to give an introduction into this little exercise, and then I'm going to give people some time to do some thinking and come up with a few ideas. So what we've got here is an intersection, and it's a road with a speed limit of 70 kilometers per hour. So 70 kilometers per hour speed limit. The side road here has a speed limit of 50 kilometers per hour default. The main road here has 22,000 vehicles a day and about 12% heavy vehicles, commercial heavy vehicles. The side road has about 2,000 vehicles a day. It's a school sort of 400 meters down the road here. What else can I tell you? That's a bus stop. It's a bus route. That's a shared user path here. That's like a drain. The water sort of comes in here and drains out there. Culvert structure. That's like a little Danish offset crossing. You know, you walk in and you walk up the road. It's backwards. It should be the other way around. You know, for Danish offset crossings, you should walk in and face traffic, right? Little random thing. I don't think that's not a major issue, but I like those facing the other way. What else have we got? We've got a turn lane, two lanes in each direction. Up here about 800 meters or so, a set of traffic signals. Down the road here, you know, it sort of leads to big growth areas. There's another set of traffic signals, a couple of kilometre and a half down the road or something, maybe a little bit more. This is a service road. They're two-way service roads. Residential area all around it. Let's have a look at it from sort of the ground level. You can see it all there. There's that bus stop I was talking about. It's got lighting. It's a side road coming in, service road there. It's from the other direction, so you can see the shared user path over here. See there, it's sort of where the water will flow out there, down that structure. Okay. So your task here is going to be to remove fatal and serious injury crashes at this location. Get rid of fatal and serious injury crashes into the future. Or do as close to that as you can. But I'm going to give you some constraints. I'll give you 3.5 million. Inflation, eh? You have $3.5 million. You can't close the intersection. So I know you're thinking back to those high-level principles or fewer intersections. Let's just close this intersection. But no, we need to have vehicles be able to come out and go right, go left, and come in from that direction and in from that direction. So we need full access to this intersection. What else? So if you're operating also in your current political organizational framework. So that, what do I mean by that? Well, I mean, yeah, if you're going to propose something extreme, you're going to have to give us a little bit of help here in getting that through the system. Okay. So some ideas on how we might work that through the system if you're going to something a bit extreme. Now, some of you are probably going, well, I don't know how much things cost. How do I know what would, 3.5 million? Well, this is where I am going to assist as the instant cost estimator tool. So if you need a cost of something, if you need, cost, just type it in and say cost. So you, I don't know, might say, how much for a grade separation flyover? And I would say $42 million. You're not going to afford it.
Amazing, Ken. You can do that instantly.
Instant cost estimation.
Jeez. Okay. Great. All right. Well, can I kick us off?
Yeah.
I'm going to go straight to traffic signals.
Oh, okay.
Oh, Henry was in on traffic signals too.
Traffic signals cost $2.75 million.
Okay, so traffic signals within budget. Philip wants a cost on a roundabout, please, with zebras on the legs.
Yep. So a roundabout to meet the Austroads Guide to Road Design 4A sort of requirements for the vehicles we've got here would cost $8.3 million.
Oh, well, that's out of budget, isn't it?
And
okay.
With zebras on the legs, $8.35 million.
Okay, all right. Phil wants a better deal on that, suggesting go to Aldi. Okay, so let's just clarify. I think some people have started putting in their responses, which is great, but make sure you put a E, an L, or an S, or if so, whatever treatment you're recommending, you tell us if it's going to affect the exposure, the likelihood, or severity.
That's right. So I didn't even get to say that. I'll reiterate it again there, Kathy.
Yeah, no,
we don't just want your treatments. We want also what risk element are we affecting? Exposure or likelihood or severity or a combination?
Correct. Okay. So, but everyone's so keen to get into this. Is left in, left out of the question?
Yeah. Well, you need to make U-turn facilities sort of within very close range, and it's just near sort of, well, it's very, I'm going to say out of the community is very concerned about this idea of blocking off and making them go the wrong way and the like. So it'd be very hard for us to do.
Can we afford a cheap pedestrian overpass?
Yeah. Yes, just given a good deal on a pedestrian overpass, and I'll just have to take your full 3.5 million.
Sounds like you're taking bribes. Okay, what else did we have for costs? No, sorry. Can we close off the service road and bring in on the road before the intersection, relocate the bus stop?
Yep.
We can do that? Okay.
Sure.
Great. Can you give us speed reduction? So Noshin, just to clarify, speed reduction, do you mean a speed limit reduction? I assume that's what Noshin means.
Is that a cost? Do you want a cost for that, or is that just
I think, yes, speed limit reduction. A cost on that?
So $55,000 just for signs and a bit of consultation, a bit of, updating the GIS mapping system, community consultation is probably the biggest part of that, and discussions and putting, you know, bits and pieces out and the like.
Could you clarify, is the service road a one-way or two-way?
It's a two-way.
Two-way. Okay, great. Does your traffic signal estimate include providing pedestrian crossing signals?
Yes.
Excellent.
Well,
all right.
On two legs. So
Okay.
the signals I'm designing here have a pedestrian crossing there and a pedestrian crossing here, but not at that location. Because, well, the traffic engineers will probably know that makes things phase a lot better.
How would the signals be designed with the service road?
Sorry. How would they be designed with a service road? Well, they could be phased in, or we could push vehicles left out of that only, or we could have that. Yeah, there's many options on that. I'm really not that concerned with the service roads.
We've got someone questioning you on the service road. It looks one way from the line marking, Ken. Let's go to the video. Okay. All right, good.
No, sorry, that one, they might have been looking at that one. That one may be one way.
Okay.
No, can't remember now.
So somebody wants to know what type of fatal and serious injury history.
Interesting question. Okay. Wondered if anybody would ask that. So the crash history.
Give a prize?
Yeah. Okay, give a prize, because I'm up for prize giving. The reason I the nard is I'm always a little bit hesitant to drive a lot of stuff by crash history. I mean, that's the way people have operated for a long time. It's not these days, it's not a great predictor of future death and serious injury. But anyway, this one's got crashes involving vehicles, crashing like that, and vehicles coming out and crashing like that. So that's our crash history, and it's about I think there were six serious injury crashes, no fatals, all involving passenger vehicles, except one, which was a motorcyclist.
Okay, now just recapping, price for a roundabout, that was in the $7 or $8 million mark, is that right? And
Right.
What about a price for a continuous footpath treatment on the service road?
Continuous footpath treatment on the service road. So continuous footpath, I assume meaning like across there. Yeah, we'll do that for we'll do both. 50,
Yes.
40,000, 50,000. Drainage will work quite well there, so you don't need to do a huge amount.
Okay, I think the questions and the cost estimating has dried up at the moment. So if you do have any further questions or costs, now's the time to pop them in. Otherwise, yeah, there's lots of responses already that have come through with the EL or S on the end, which is great.
I'm going to give people maybe another couple of minutes to do this.
Yeah, for sure. One last cost estimate, raise safety platforms.
Okay, so raise safety platforms on the approaches to the intersections and the main road approaches, they'd be 350,000. If you want to raise the whole intersection, add 500,000. If you want to do a raised thing on this approach, that would be 40,000. The arterial road raised things are a bit more expensive for a variety of reasons.
Okay. All right. So shall we go 4 minutes?
3 minutes, I think, because
3
some
minutes.
people have already put stuff in.
Yep.
Is that all right?
Yeah, absolutely. And so pop your responses in, make the 3 dots so that everyone sees your responses, because it's always good to build on other people's ideas and see, oh, sorry, what was the side road road safety platform?
40,000.
40. Okay. The whole intersection was 500 and just some
350,000 just to do both approaches.
Okay, great. Yeah, pop your responses into the chat as you're going along. Okay, sorry. Cost estimate for protecting drainage hazards.
So yeah, some barrier system and the like. 45,000 just on short lengths of barrier system, protecting road users from the hazard there.
Okay. Good. Great.
Good questions. This group's good thinking, lots of ideas.
Lots of thinking.
And lots of good exposure, likelihood, severity categorization. That makes me happy.
Mm.
Give it another minute.
Mm-hmm. Then actually we can cover up a question we had earlier, if you could.
Mm-hmm.
There was a question about, can you tell us what a secondary crash is?
A secondary crash is when there's been a collision of some description between vehicles. And then there's a second crash into roadside hazards or into pedestrians or into others. So, but it wasn't the first collision. And so, yeah, so we do often see that at intersections where like the vehicle's pulled out, say like this white vehicle and a car's coming up here and they, avoid, but they maybe clip that, which sends them off the road and then they, run into a house or a tree, and that's a secondary, that's the secondary collision. That's the initial collision.
Got it. Great.
And so there is a bit of sort of safe systemy thinking in that as well, because in traditional, ways of operating in road safety, all you'll be doing is focusing on stopping that initial collision, stop the vehicle, give them better sight lines and these sorts of things. You're sort of ignoring this secondary one because you want to stop the first one, which is laudable. And, it's something we should be trying to do everything we can, but we've got to now start thinking about these secondary ones as well. All right, I think that's probably enough time, Kathy?
Definitely.
I'm just going to erase that. And I'm going to have a look at what we've got here when these wonderful people have come up with their ideas. Sorry, I'm jumping around the place here. Okay. Here we go. So I like the fact that people, very quickly were starting to, ask, what's a roundabout cost? And people were quite interested in this roundabout idea, and I've got some slides to explore why maybe people were thinking about that. And we had lots of people thinking about different things, and then we started delving into, okay, let's go to the exposure, likelihood, and severity. And we had some people asking, well, can we block off bits and pieces of this? Can we close the whole intersection? And I clarified, in this occasion, we can't, but that would definitely reduce the exposure to crashes. It would eliminate the exposure to crashes involving vehicles coming out and being struck. It wouldn't change our exposure to pedestrians crossing and being struck, because we'd have the same number of pedestrians crossing and we'd have essentially the same number of vehicles along here, but that intersection related crash would be down. So that is an exposure. So we had a nice one there from Kip suggesting side road activated speeds on the main road influencing severity. That's right, absolutely. So a side road activated speed would sort of say, well, we're going to slow the vehicles on this road down when there's vehicles coming up here to try to get out, because there's a risk at that time. So you can do that with electronic signs. And that would influence the severity of crashes if we can bring these vehicle speeds down. It would also actually reduce the likelihood of crashes as well, because as bullet vehicles are traveling at lower speed, they have more time to react. So they have more time to evade and the like. And then when crashes happen, they're at lower speed, lower energy. So we actually get sort of double benefit off that. So people wanting to close off the service roads, and then there's a little bit of confusion, it seems, as to what that helps us with. Does that help us with exposure or likelihood or severity? So really what we do, because of the relatively broad brush nature of safe system assessments, is say that would influence the likelihood of crashes. I think it would only be a very small reduction in the likelihood of crashes, but nonetheless, because the reason for that is that it's really not influencing the number of vehicles exposed to crashes at this location. That's predominantly done by, the major volumes here and the major volumes here, and that's your crash. So, coming out of here is going to cause a little bit of annoyance and turbulence and things here, but a minor number of, increases in exposure to crashes, right? So it might make things a little bit simpler, and that's all good. But all this is going to be happening at fairly low speeds. So I really don't have a huge amount of concern about that. It's when you've got vehicles coming through here at speed and things go wrong, that's our issue. Now, if you were to do like a very, very refined safe system assessment, you could argue an change in exposure by closing their service roads. But essentially what you would have to do, and it would just be so weird for anybody to do this, but you technically could, is that you would have to sort of say, right, I'm doing actually like all these different assessments. I'm doing an assessment here. So this will be assessment 1, this will be assessment 2, this will be assessment 3, and this will be assessment 4, this will be assessment 5 and 6 and 7. And then you would say, well, for 3, we've changed the exposure to intersection crash types because they're the intersection. But yeah, you wouldn't do that. It's just so much overkill for what we are doing with these assessments. Okay, where were we? We were also seeing there, reduce the speed to 50 kilometers an hour. I'm not sure how we were going to do that. Speed limit reduction potentially for those doing it. And we've got some people now saying signalizing the intersection. They've sort of, a number of people have got to that point because they go, oh, we can't afford that roundabout we were thinking about. Okay, maybe we've got to go to signalization. Now, some people want to move the bus stop. Okay, that's fine. So they're not liking the bus stop location close to this intersection and it's happening. So maybe they're moving it down here potentially. And you do a bit of thinking about pedestrian desire lines, where people are coming from and going to and that, I'm sure, before you did that. But nonetheless, now what would that influence? Exposure, likelihood, or severity? Well, that will influence likelihood. Okay. You can't, again, really say that this is going to influence the exposure to any crash type, because all the crashes that we were thinking about when the bus stop was here are still in our general vicinity. They're just happening down here. Be that a pedestrian crossing the road, be that the turbulence of the bus coming out and people going around it. It's all happening. So again, as long as we sort of think, okay, our safe system assessment is of this whole area, that's still exists. Just having a look here. So then, interestingly, we've got some people talking about raised safety platforms and different raised intersections and raised bits and pieces. Now, that's interesting. So some people seem to want to raise, things in this general area. And then we saw some people wanting to raise things out here as well. Okay, so that's quite interesting. The reason I sort of say that's quite interesting is because certainly 10 years ago, nobody ever would have been wanting to raise anything in that area. Why? Well, this is a fairly major arterial highway. It takes freight, buses, and you don't do vertical deflection on those, or that was the thinking. People would think about raising these threshold treatments and the like, and they have some advantage, but from that vehicle to vehicle crash type, really not too much advantage. They would have more advantage of pedestrians sort of crossing at these locations, maybe slowing vehicles coming in, and certainly slowing vehicles coming out. But at a T intersection like this, the vehicles on the side road, well, they're not really the bullet vehicles, are they? They're not the ones doing damage. These vehicles that are doing the damage. So they're the ones we should be trying to address the speed to get it within what we're thinking about as tolerable levels for the crash types we're particularly focused on. I'm just reading through, seeing if there's lots of great responses, and I'm not going to get through them all.
And I think we have to give a shout out to Anthony because he's detailed everything, including the cost for everything, and given us a total. If you, very,
and it's a bill of quantities at the end.
Yes, yeah.
Good, excellent.
Tell us, though, there are still many in capital people in the industry that do not believe in devices such as platforms on major arterial roads. That's considered LATM, local area traffic management, to them.
Yes, that's a very good point. That deserves a prize. And we're trying very hard to continue to get people educated and thinking, and lots and lots of examples out there of where it's been done and it can be done, and it's not the end of the world. And it's, it's big change. Like, as I say, 10 years ago, if you had said, if I was in my Vic Roads office 10 years ago and said, hey, why don't we do a raised intersection through here? Oh, would have been kicked out of the office for sure, or laughed out of the office. But, we're progressing now, but some areas are slower to progress. But how do you get big change to happen? You show lots of examples, you show it can be done, you do trial areas and trial sites, and you move things forward. But let's have a look at some of this. And I suppose the other thing is that I've been running this course for a long time. About 7 or 8 years on safe system assessments, and nobody was interested in in it for the first 5 years. And we did these sorts of exercises though, and we would get a group together and we do these sorts of exercises. And with a group like this, I'd never get anybody who would say raised intersection. But now I get a good amount of people in every course suggesting that. And it shows that people, industry's we're getting progress. We're getting that thinking. People are understanding these things. And with a safe system assessment, you're starting to push people who don't have that thinking with these, defined, sort of somewhat official looking assessments. I'll talk more to that as well. But I'm going to run through a few slides, and I'm going to refer back to that intersection, and we'll come back to it a little bit later. But a lot of people did come to the conclusion that signalization, with the costs, the dollars we had available, was probably going to be what was going to be needed of some description. And signals influence the likelihood of crashes. When we're doing safe system assessment, anything signalizing will influence the likelihood of crashes. Now, you probably got scenarios conjured up in your mind of where signals will reduce the severity of crashes as well. And yeah, some crashes, the severity will be reduced. So somebody will be braking late and it'll be a lower impact crash. But we are thinking about what can still remain, or what is more likely to still remain, and that's high speed crashes of people running red lights and going through these signals. And you can pretty much just heat map death and serious injury around any major city in Australia. In the outer areas where the speeds are up, and the hotspots of death and serious injury, as I've done here for outer sort of suburban Melbourne, they're all signalised intersections. Right? Now, we know that there's that spike in risk, but the intersection form that we're providing there, it's not giving us the ultimate in what we want in road safety. But sometimes it's really thought about as we've done everything we can. We've got traffic signals, it's got mast arms, it's got LED lights, it's got red light camera, and yet we just still see it come out. The top 100 intersections for death and serious injury in most states will be absolutely dominated by large signalized intersections. And people just go, well, there's nothing more we can do here. People just have to, stop running the red lights. This is now a behavioral issue, not our issue in the engineering of it. We've done our job. We've got to challenge that. We really have to challenge that. First of all, we can't just, first and foremost is we can't just continue to build these and think that we're going to get some sort of different result. Right? They just keep coming along, and they're built exactly the same as the one down the road where there's been death and serious injury, or all the ones around it. So this has got to change. And safe system assessments are a good way to do it that maybe aren't as inflammatory as some other ways. In fact, Kathy, I'll show the next slide or two, and then I'm going to dig something out of my archive, which is a bit more inflammatory way of, I used to try to do it. And now we've got safe system assessments, but roundabouts. Oh, sorry, Kathy, go.
No, that's okay. Did you win many friends and influence people that way? Or?
Yeah, no, Dale Carnegie would be angry at me. Yeah, in my approach. Okay, but roundabouts, I like the fact that a lot of people came at roundabouts at an early stage there in that example we had, because roundabouts address the severity of crashes for passenger vehicles, right? Actually, severity of crashes for all crash types, but we have some other challenges with pedestrians and cyclists at roundabouts, which I'm going to talk, well, actually, Max McArdle is going to talk to you next session in a bit of detail around some of that. But for passenger vehicle crashes, the severity of crash is significantly down. So this is obviously not the same site, but I've got this one up because look at the size of this thing, right? The land take on it's big, eh? You know, that's why it was so expensive for that roundabout. We have to take out some houses and we have to, you know, move services and it's very expensive. Why do they need to be that big? Well, the theory is at least that a large vehicle needs to be able to make their turn around that or swept path, you know, around that. So it needs to be large. There's some challenges also apart from the size when we are thinking about traffic and roundabouts. Unbalanced flow. We had sort of unbalanced flow becomes a little problematic with roundabouts. You get one leg will dominate. It'll cause other challenges. I often challenge that one though and say to people, don't throw the baby out with the bathwater there. We can meter roundabouts. Metering a roundabout is to add a set of traffic signals. So, for example, we could put a set of traffic signals here and a loop in the road back here. And, you know, as the vehicles queue up and we recognize somebody's queuing all the way back to there, we go, okay, we're going to, you know, stop vehicles here and we let them sort of flush out. You know, you could just an easy way to meter is to just have that, you know, stop there. So all these vehicles can come out. If, depending on how you've worked it out, if you can make this a signalized crossing point, I love that. And you can get a nice, you know, shared path that comes in here and you've got a nice crossing and these sort of things. But, you know, you play around with them. So you can really extend the life of roundabouts. And if you're thinking about them from that just pure traffic perspective. And this is often what happens is that, and the traffic engineers and traffic modelers look at all these outer suburban areas and they're congested with cars. And, you know, that's a bigger issue in its own right is that why is everybody having to drive a car in these areas? And, you know, I'm putting that sort of strategic planning part aside and, you know, lots of work to be done in that space. But the easy sort of ways to get congestion down is, you know, duplicating roads and removing roundabouts and replacing those roundabouts with traffic signals. It'll make the network flow a bit better. Now, it's interesting. I was in the road safety department in a state government authority, and there was a big, massive, you know, Australia's biggest ever, this is back in the day, congestion easing program that was coming along. And throwing heaps of money to try to, well, it was called Keep Melbourne Moving at the time. And this is where I was going to share something else, Kathy. I was going to show you something that I did take when I left a while back. Because what was happening was the modeling has showed that, okay, if we rip all these roundabouts out, replaced with traffic signals, we're going to get a little bit more easing of congestion during peak times for cars. And they then design those up and they send them to the road safety department and others. And we were to do a safety review on it, sort of like an audit. Well, it was a desktop review. It wasn't an actual road safety audit, desktop review. And we were looking at, you know, they were asking us essentially to look at, you know, is the phasing right? Of, you know, the line marking right? Is it on pedestrian desire lines? Do we need connections of footpaths and all those, you know, bits and pieces that they expect us to review? So colleague and I started. We did all of that, of course, but then we developed up this memo, and I'm just gonna. I don't. Is that sharing the memo, Kathy, or is that?
It is. If you could make it a bit bigger, perhaps. Oh, there we go.
Okay.
Thank you.
So this is the template one. Yeah, so from the road safety department, blah, blah, blah. Okay. The road safety department has analysed this project as increasing crashes as follows. The project life, you've got to put a life on these projects to do analysis. Number of deaths attributed to the project, 2.3. And we had some little pictures of people. to remind them they were going to kill people. Serious injuries attributed to this project, 12.6. And then, yeah, this bit, statement of acceptance. The above road trauma is accepted by regional manager. So that was the covering memo with the safety assessment report that we used to send back until we got a call to go and visit the chief executive, and very nice chief executive, actually, who just gave us that nice, talking to about the responsibility of a road authority is very complex and many competing demands and blah, blah, blah. And, we know that. We're trying to, make a point here that somebody needs to, stand up and say we value getting a few more seconds per vehicle more than protecting our community. And anyway, so we had to stop doing that.
Did you get any signed?
No, of course not. But what it did do, stop that. What it did do, I suppose, was rile up some good discussion and some good questioning. And the reason I said that, that's an inflammatory way of doing things, a safe system assessment kind of does that, but in a more, in an approach that's not so, inflammatory and graphs, and it looks very sort of scientific. Mind you, the way we did that was probably more scientific than the way safe system assessments are done. I mean, safe system assessments have a bit more subjectivity to them, a bit more sort of professional judgment style stuff. That one, we used some predictive modeling of crashes, which still has subjectivity. But like people, when people come along, and I've experienced this so much, is they arrive at a proposal, an intersection upgrade proposal or the like, and the SIDRA report, like the traffic modeling report, gets put on the table, right? And that is just taken as absolute gospel. Oh my God, this is going to drop it to a level of service C or whatever it is. We can't do that. Absolutely not. But then like a road safety audit or something is put there, and it's not even that, well, first of all, people have their opinion on whether it's going to be safe or not. And the audits are quite fluffy, but the audits are only just picking out risks. As I talked about last module, like the audit will just have all these risks of whatever you're planning. So the safe system assessment, though, can really in your face put, this is what we expect to happen. And it kind of has that same feel of that report with numbers and graphs, and there it is. So that's an advantage. Any questions or comments on that, Kathy?
Yes. And yes, very good. Anita says they did try metering on a roundabout in Toowoomba years ago, but it wasn't accepted by the public. It was too technical for the country folk, perhaps. And Anthony says, I'm sick of traffic reports that are basically just SIDRA models.
Yeah. I agree. And it's so funny, like people just go SIDRA, oh, that's what the SIDRA says, and like no arguing, no whatsoever. And I'm like, I don't do SIDRA myself. I 20 years ago did a bit of SIDRA, but I've got these SIDRA absolute gurus in the company, and you just go, how does it work? And they're making assumptions left, right, and center. Like they could tweak it however they wanted. I mean, they're pretty good at making logical judgment. But if anybody questions how valid a safe system assessment is, and we're making some assumptions too. Anyway, okay, I better keep ticking along unless there's other questions or comments.
Yeah, no, you've got lots of fans here jumping on the crap on SIDRA bandwagon.
We're not crapping on the
Oh, sorry, I'm putting words into it. Maybe
I'm just saying that you got to recognize it for what you put. These the black box models of that just are so funny in that.
The problem is that the powers that be are willing to put traffic flow ahead of other community needs, including safety.
And that's right. Well, it's an interesting one. Why is that? I mean, it's a very
GDP, isn't it, Ken? Isn't it all about the GDP?
Yeah, a few seconds extra here and there. But more than that, Kathy, actually, it's that everybody, well, a lot of people feel the effects of congestion, but not a lot of people feel the effects of the death and serious injury. So you're comparing a large population to a very minor inconvenience versus a very small few who just have absolutely horrific outcomes. And so the politicians are going to go on the bandwagon, and others are going to go on the bandwagon of the big, oh, well, I can make everybody a tiny little bit more comfortable, and that will erode, and they'll be angry about the next thing within an instant anyway. But you know, so that's where it's hard.
Okay, all right. So you've left us on a feeling down now. We need to have a break soon.
Let me finish some roundabout stuff, because I can do this pretty quickly. Great. I mean, I just also question why roundabouts need to be as big as they need to be. Now, don't get me wrong, very different road environment here, but this is a UK example. And what we actually see is really significant benefit from these sorts of roundabouts. But the reasoning why is slightly different to what people think is the whole sort of benefit of a roundabout. Like people, when they talk about roundabouts, they're always on about deflection and these sort of things. And that's very beneficial. Yes, I agree. It slows you down. But don't forget, you get actual huge benefit by everybody approaching this. Well, nobody approaching this thinks they have ultimate priority. And that's good. That's a good thing at an area of high risk, that they will slow down and look around and be more alert. Okay. So the deflection, so this is kind of the UK equivalent, this one, of the four-way stop scenario. And I think we should recognize that benefit in its own right. If you're worried about speeds, then through that, some small raised sections slow people down, and we're still so much cheaper than trying to acquire massive land and the like. And here's that conflict point, or a conflict point diagram. So, you know, absolutely road safety engineering 101 here for you. Put roundabouts, just less ways for passenger vehicles to crash. We will talk lots about pedestrians and cyclists through roundabouts shortly, because I very much want to ensure we do that. But there's just a lot of ways to crash, and a lot of nasty angle crashes at signalized intersections. The angles can be very bad, and angles are better at roundabouts to crash. And the other one is, this one's a bit subtler, but it's really interesting that when people approach an intersection, they are in all states of consciousness. We would love them to be alert and awake and really concentrating, but they're not, a lot of them. They've worked a double shift, or they're thinking about the fight they had with their partner, or they're daydreaming about something else, or the like. And they're in all states of consciousness. Maybe they've had a few drinks. Yeah. And we want them to be alert and compliant and sober and everything like that. But the reality is there's so much not. But if we have a lump of infrastructure or something there in the middle of the road that they have to interact with, they come back to it. They come back to reality. They look around, they slow down. A set of traffic signals doesn't do that. The geometry of the road, the straightness of it, the nothingness of it, means that just some people don't come out of their days and they go straight through at speed. And, some of you will have driven in this state, no doubt, and you don't remember the last 5 minutes of driving, or you went, oh, did I just go through a red light? Yeah. And these are, that's just a lot of people doing that. But that, that physical infrastructure can alert people at those points that we know spike in risk. And there's lots of different roundabout options and things. I like the fact that people have been delving in lots of detail about roundabouts and double lane roundabouts, single lane roundabouts. That would have had to be a double lane roundabout. We have this possible issue of higher speed through it if we're doing it. So you can see here some interesting speed versus radius, and double lane roundabouts, small or very high speed can be through. Good proxy for safety always there. Turbo roundabouts though, just for your interest here, turbo roundabouts, double lane roundabout operate essentially as good and everything as a single lane roundabout. So you can see turbo has a raised separator on the approach, raised separators in the roundabouts. You want to go right, you get yourself in that right lane and you come around. And you want to go left, you're in that lane. Stops people taking straight lines through it. So interesting one. Nice bike facilities under this one, doesn't it? That's what we're talking about. Here's a nice turbo. And I love this aerial image because we got conflict happening here. Oh, well, we've got a truck coming out, making a mistake. Got this white van coming in here. We can, just from this, we see it, we go, if that crash happens, it's going to be low severity. It's going to be low speed. Everybody's going to walk away from that for sure. If a truck had made a mistake on a large signalized intersection or the like, we would see high speed and high severity. Interesting, very radial roundabout here, isn't it? So that's an interesting one for those who like roundabout design. Not that sort of tangential one. And we'll have a break after I show you this one, which I think is cool. But why am I showing this? Well, it's more just a philosophy, a different way of looking at things, because this is in the Netherlands, and flipped it over because they drive on the right, and that would just boggle our minds beyond repair. Because it looks, I don't think, I've not driven this or walked this or ridden this, but I think it would not be as bad as it looks from up here. But the thing is, I had a Dutch engineer, we brought one out to talk about roundabout design for cyclists and do lots of bits and pieces. But I showed this one, I said, I find this amazing because, in Australia, I mean, just the land take on this and the complexity and all, in Australia, it would just be a large signalized intersection. It might have got to grade separation at some point, but probably a large signalized intersection, high-speed roads. And the Dutch engineer just went, but what about all the death and serious injury? Like, how could you do that? Like, couldn't fathom that you would kill and seriously injure your community like that. I'm like, yeah, I agree. And they would rather, this sort of setup. Well, and it's not even rather. I mean, there's no even consideration that you could operate a signalized intersection at the speeds we operate them at. And yeah, anyway, I think it's an interesting one there. All right, let's just have a quick break, Kathy. 2-minute break.
Yeah.
2.5.
You're 2.5 is great. Lots of commentary in the chat for you to have a look at. Lots of good thinking happening from everyone sharing their thoughts. Fantastic. Thank you. And Anthony's also telling us there's a modified turbo roundabout in Seaford, South Australia.
There's one. There's one out in Horsham now as well, and so.
I think everyone's going to have a look at that link that he just sent through on our 2.5-minute break.
Okay, let's get back into it. I mean, in 2.5 minutes. Well, I do like the fact that people are out there now challenging signalized intersection design and big signalized intersection design and say, well, what can we do to give us some of those safe system aligned principles to really start to address the severity of crash. I'd give this one probably likelihood as well because of the signalization. But, these sorts of things, slowing vehicles on the approach, changing the angle, disrupting the dazed asleep driving mentality. Now this is just a mock-up, but people are trying to look at how can we do this? How can we make this somewhat safer? So that's a cut through roundabout. But raised safety platforms, we already had a good bit of discussion about this, so I don't need to go on about it too much. But these are now becoming a more commonplace practice on major arterial roads in Australia and New Zealand. We've got a lot of work to do in some areas and some jurisdictions, and people are reluctant to it because it's different, it's new, it's a change. But that one is one where they ended up doing what I hope more people will do and saying, well, if we just build another set of signals, probably going to have to accept some death and serious injury that's going to come with it, because we know that's what happens. But we're going to need to change it up. What else can we do? How can we slow down the bullet vehicles? And the bullet vehicles are going to be these ones, aren't they? Or these ones coming in. The ones coming out here or going in here, they don't have the speed, so you don't need to disrupt them. And so they went with, raised platforms on the approach, signalization because of the costs to get some slightly better pedestrian access, to get some better cyclists crossing from the shared path and a few other bits and pieces. It all fitted together nicely, consistency of treatment. And so that one was built. Now they went with a 50 km/h advisory speeds. So the ramp grades are not like a urban speed hump, right? They're just trying to bring those speeds down a bit. Now that's not getting us within tolerable limits for the pedestrians and the cyclists. They'd made that sort of determination that this was the major concern they had was vehicle-to-vehicle crashes. This is a major traffic route and all those other things. But I think that what they ended up doing was really quite impressive. So this is Surf Coast Kidman Highway. This was the first sort of one. I was out there with a colleague doing the post-opening road safety audit on it and looking at bits and pieces. I took this photo, and I really like this photo because we've got a vehicle braking on the approach to a green light. And that shows that we're disrupting people's monotonous driving, half asleepness. It, sometimes I've shown this to different groups and the like, and some traffic ops people get angry. Oh, this is so annoying and inefficient, and for a very small percentage of people, we're impacting on everybody and the like. It's ridiculous. If we'd put a roundabout in there, everybody would be slowing down. I mean, nobody would be making that sort of comment, would they? It's just that we're not used to doing this for traffic signals. So we try and disrupt that and challenge that. Another sort of spin-off advantage is the reduction in the dilemma zone. So the dilemma zone is that point in time and space where you're the driver's in a dilemma as to, do they put the foot down to go through the orange light or do they brake? I'm sure you've found yourself in the dilemma zone. And what another great naming by whoever named that. The official name is a dilemma zone. But the dilemma zone just absolutely shrinks with the presence of that raised platform, because people aren't going to put the foot down to go over it. So wonderful, other spin-off advantages. Now, there have been some evaluations of these raised safety platforms done now, independent evaluations. So ARB did one. We've had some stuff out of New Zealand now. There's an Austroads document. They're all showing wonderful benefits, not just for the passenger vehicles, but pedestrians and cyclists. Everybody's benefiting. And we're seeing them getting more and more rolled out. But this case study, this little one here, I say little one, is fantastic. And okay, there's some little design tweaks I'd like done. I'd like that much lower and more sharper there. But anyway, that's okay. And then the construction and how they did it. But the reason I love this is Dalton Childs Road. This was a roundabout. And guess what happened? Another congestion easing program. Big congestion, rip the roundabouts out, replace them with traffic signals. So we know, 15 years later or whatever it is. But guess what they all had to do? Safe system assessments. Right? And guess what the safe system assessment said? You're going to make things worse by doing this in terms of safe system alignment. And we suggest you think about slowing vehicle speeds through this intersection. And so they created a raised platform, raised, slowed everybody down. This is not a minor road. Dalton Road carries 55 at least 1,000 vehicles a day. Major bus route, heavy vehicle route. It's where the emergency services go up and down. And now there's at least 3 signalized intersections in a row that are raised. Okay, we're starting to see this as that. Yeah, we slow people down at conflict points to within tolerable limits, or very close to it. So progress comes along. It can be slow. It can be frustrating. But the more sort of things we have, like these safe system assessments to put down to challenge, we can get some traction. And in terms of things like guidance, okay, we're seeing better guidance now. Victoria's got race safety platform guidance. We've got this Austroads report, and that's quite a good one. We've got lots of examples there, as I showed you. I think there's about 15 across outer metropolitan Melbourne, and some now in regional Victoria. We're seeing New Zealand's done 2 or 3 now, and more to come. We've got South Australia's got a couple of things that are sort of in the realm of what we're talking about, and a few other states lagging a little bit on starting the ball rolling and trialing them, but we hope to see that happening. Any questions or comments on that? I think what usually happens is we get people who come to this course who are safety champions and the like, and they're all supportive of this and frustrated that they can't quite convince some people to make this happen. But I empathize and encourage.
Okay, so tell us, does Dalton Road still have its 70-kilometre-an-hour limit?
Dalton 60, I think. But yeah. So yeah, 60 or 70. No, 60, I think, at that location. And Phil's on there. Yeah, Childs Road's about 25,000. Yeah. Yep. They're big roads. Yeah. They were really pumping traffic through. So
are there any limitations to road safety platforms, heavy vehicle use, visibility?
So yeah, there's some design specifics. I think that Austroads report's done a great job of condensing that alongside some of those Vic Roads supplements. Yeah, that's good. Actually, Phil's given them the thumbs up for trucks, and he's the truck guru. So that's good. Yeah, what there are is just a heap of things that people think will be issues, and they are like, people go, oh, the noise will be unbearable. Kathy sort of just shown that one. The Dukes of Hazzard, they think people are going to hit it like at 100 kilometers an hour and then just like launch over houses and stuff. They think that the whole world is going to flood as a result of this and these sort of things. Yeah, like, and all the freight, whatever they're carrying, is going to be crushed, and like, these are all things to think through, but they're okay. Actually, funny story, and I'm going to have to go quick now. for Surf Coast Kidman, there was all this concern. It had never been done. This, people just, these titans of industry just, laughing at the idea. This is the stupidest thing I've ever heard, all that sort of stuff. And, all these issues. And so what they did is they got a road. It's called Gundog Lane, which is a local government road, but a high-ish speed local government road. And they built raised safety platforms along it of slightly different ones, different grades and things like that, but generally what was going to be built. And then they use that as an area to show people and then to do evaluations, to send trucks through, buses through, motorcycles through, to see how this all worked. And it was also a really great communication tool, because when people complain, they say, we've built some down here, go and drive it and see what it's like. It's not like an urban speed hump. It calms people down. Plus, you also get some local area traffic management on that Gundog Lane. Not that many people use it because it's not a through road anymore. But so I like that as a little way to move things along.
Now, people are asking for some additional information on that upgrade. If we have anything, can we share some stuff there?
Don Childs?
No, the Kidman, Surf Coast Kidman.
Yep. Just trying to think. Yep.
Okay, I'll note it down. And just back on Surf Coast Kidman, so there was no pedestrian crossing on the minor road? Did they only put signalised pedestrian crossings?
Oh, no, there was signalised crossing on the minor road too.
There was? Okay, great. Okay, I think we are good. So, yes, Gundog Lane. I love this. People are just all over this. Was Breakwater Road, a former arterial road, so a good example to try it on. Lucas is giving it the thumbs up for what happened there. Great.
Good. Thanks, Lucas. Thanks for doing well. Knows this whole thing beautifully. Okay. Just a quick one back on roundabouts, and another lovely example. We won't sort of do the same exercise, but this is intersection here, rural intersection, high-speed roads, 100 kilometres an hour in both directions. Wow, they had reduced one to 80 to try to lessen the trauma. The arterial road sort of goes around that way, but they said let's build a roundabout here, and so they did a conventional roundabout design, and it was massive. I had to take out that and take this house and this and move this telecommunications exchange and do these reverse curves on the approach. And it was just, the cost was absolutely blown out. So then they went, okay, well, we'll just do some warning signs and a right turn lane. And they did it. And again, the safe system assessment said, okay, well, in this case, you will improve things in terms of reducing the likelihood of crashes. You're doing nothing for the severity of crashes. And, you can do a whole lot more here. And pushing then. And so they went back to the drawing board. And so this is where, again, they came to the point of saying, well, we want a roundabout. What about a smaller roundabout? And you can see here, the roundabout itself is actually just that little circle. And that's concrete apron and some speed calming devices to just slow vehicles on the approach. And so that one is the Lance Creek compact roundabout. And you can see some, raised platforms, a bit of a raise there. That's to sort of supplement the reverse curve speed calming on the approach to the roundabout. You can see in there, you've got a little roundabout, so a large vehicle can track over that, but hopefully smaller vehicles will go around it. I can send you the detailed designs on this. And I did a conference paper on it because we've written some compact roundabout design notes for the Victorian government. Actually, that's publicly available now. So like, how do you design these? How do you think about it? Lots of little tricks around designing these because of bits and pieces. But that's the point of that's not about the details of designing this. It's the principle that, right turn lanes and warning signs and things, okay, they're okay to reduce the chance of a crash, but we need to fundamentally address the severity of incidents, slow vehicles down at these conflict points. And here's another good example of innovation and pushing and trying to change things. Quick quiz, Kathy, and then we're going to give people a little assignment at the end of today, aren't we?
You certainly are. You don't go away from this just happily listening and writing in the comments. So the quiz that's popped up, it should say, true or false, traffic signals are not safe system. True, false, or unintelligible question. Maybe that's questioning your questions there, Ken.
Yeah, it's saying, what do you even mean by this question? Or what, this doesn't make any sense. Like, so true, false, or unintelligible question. Let people ponder that.
Actually, people are giving me a lot of homework to do after this session. Lots of things to pop into the learning management system. Untreated traffic signals are not safe system. Ooh, untreated.
Yeah, okay. And that's a bit of the, Well, this is interesting, isn't it? We should say we can see the results as they're coming in, and we'll share them with everybody in a second.
I think I'll do that now. Okay, this is what we had.
Well, to a degree, unintelligible question would be a good answer because there's no context to this whatsoever, is there? They haven't sort of told you what the speed environment is and these sorts of things. I could accept true if you've got a particular context in mind that, it's high speed and the like. And as people are saying in there, the signals are, an administrative control and they're not doing any of these bits and pieces. I could accept false if you've thought, well, it's not the traffic signals themselves, it's, where they're put in the environment, the context. So it'd be nice, let's say everybody's right as long as they were thinking in the context. But the reason I do it is I say that we can absolutely still continue to use traffic signals in the road environment, and we can do it in a very safe system manner as long as we supplement or ensure that speeds are down to what we see as within tolerable limits. Okay, let's get rid of that. Oh. Okay. A few key takeaway points in the notes if you want a written summary of some of those things. Lane departure crash is interesting. I mean, maybe just type in the chat. Here's a road, 100 km/h. It's got some sealed shoulders, and it's got center line and a very occasional minor intersection that goes on for about 400 kilometers like this. It's pretty much straight. What crashes are we going to see here?
You're asking people to type something in, or you're...
Yeah,
okay, great.
Maybe about 3,000, 4,000 vehicles a day.
Oh. Okay.
Yep. That's right. Everybody's on it. Head-ons and run-off road crashes and people sort of indicating what might have sort of generated this. Mainly people falling asleep, being maybe distracted, drifting in and out of their lanes and leaving the road. And we see a lot of it. And it's just, to pick an individual spot on these types of roads as sort of significantly riskier than other parts is near impossible. We see this distributed out along these roads. There's minor increases in risk around curves and other bits and pieces, but there's plenty of death and serious injury on the straight bits, because we're just inherently, having energy just way beyond tolerable limits throughout this whole thing, and relying on the humans to be in their lane and be alert and compliant the whole time. It just doesn't happen. So leaving the road, as I say, people tend to drift off the road and then wake up in the roadside or in the other lane or the like, and make a move to get back to where they should be. And that move to get back where they should be often generates yawing. And yawing is the side to side of the vehicle, the sliding. And then all sorts of chaos happens. We see people come back into their lane, but then we see some people overshoot and go shooting off the other side of the road, going double yawing, and some roll, and then some hit trees. And they often hit trees on the side, with the side of the vehicle because of that yawing. And so it's a very sort of chaotic event, these run-off road crashes. We know that we saw that 29 kilometre, now 32 kilometre per hour side impact pole test. We know that as a vehicle's yawing and sliding through the roadside, if it finds a point source hazard, a tree, a power pole, or the like, it's going to be so much force imparted. Now, this one, here's an example, and this is a bit graphic, so turn away if you need, but this is a predicted 60 kilometre per hour strike with a power pole. And this is sort of to show you the violence, the huge energies we're talking about. And they're just, you're not able to withstand that sort of a crash. So clearing roadsides of fixed hazards, power poles, trees, culverts, and the like, that reduces risk, but only there's a limitation to that. And you can see how this sort of asymptotes out around that 4.5 casualty crashes per 100 million VKTs. Prize, if you can tell me what VKT stands for, first person to do that. So we see that, cleared areas in the roadside are better, but there's some interesting practical challenges with that. So whoever said vehicle kilometers traveled first is correct. Kathy will work that out and give a prize. So the other point around this idea of clear zone is that we don't want to create clear zones anymore. People did in the past. Maybe people still do want to, but that's, the vegetation and the removal of trees, it's just not what we want to do. And back in the day, I suppose that was the best thing we had, but now we have better options, or in a lot of cases, we do have better options. So clear zone theory has been taken out of Austrade's guides. So in fact, if you look at now the Austrade's Guide to Road Design, Part 6, it does not include clear zones. And so what we are thinking about now is, and the reason for that is people used to take like this weird approach, which was like, if you distance from the edge line and then like risk. And it was like they'd calculated a clear zone, say they calculated it at 9 meters or the like, based on, the speed and the vehicle volume and those things. They were acting like 9, so that's 9 meters. They were acting like it was this. I was like, risk, and then. So what we ended up seeing was all these trees and power poles and everything like at 9.1 meters. And you'd see brand new roads built and everything sitting at 9. It was like, oh no, it's 8.9. We couldn't possibly do that. 9.1, fine. No, not a hazard. So that sort of got eventually moved out. Plus, it was based off 1960s research and lots of different questions around that. So where we're at, like, is that we know wide clear zones are not necessarily a safe place to be. You probably get your most benefit around the 4 to 5 meters, but you've got to consider all of the world we live in now is not one where just, clearing all your vegetation is appropriate. So we won't see these sorts of roads being built. I mean, this 2 years ago is exactly how Part 6 would have told you to design a new town bypass on a major road. Well, maybe not that, but sealed shoulders, and actually probably not the truck rumble strips, but all your hazards, offset, whatever your clear zone is, and then big wide median, which will be clear zone calculated, and off you go. But we see lots of death and serious injury on this road. This is the Hume. We see it on, Pacific Highway and Bruce Highway, and you name it. Lots of people running off the road, and tragic things when you see $1 billion spent creating a new road like this, and within months of it opening, a car goes across the median, whole family were killed. And that was within months of the minister cutting the ribbon on a road like this. And so just horrific. The new Part 6 has got some interesting ways of doing it. Lots of good stuff in there. Still some things we need to keep working on. But it just sort of simplified the whole idea that the continuous barrier systems is our highest alignment with safe system principles. People will leave the road. They will leave their lane. And we need something there to manage the energy. And it's interesting when you look at sort of different road cross sections and star rate them, the same way you star rate the fridge for energy ratings, you can star rate roads for safety. Bit hard to see, but that's a 4-star road with this big cleared area. Barrier systems, barrier systems, barrier systems, that's a 5-star road. Anyway, I won't go through each of those. How we do it, the specifics of the design, thinking about vehicle breakdown, all important stuff to do. We need to ensure we can get this out. There's good design information out there now on how to do all of this stuff. I'm not going to go. I want to finish on this one. And again, I'm not talking about the specifics of the product or anything like that. I will talk about the product, but I want to talk about the principles. And the principle is thinking about energy and energy management in our designs and doing more of that. So this is a old Ford, and it's that classic scenario that we all get frustrated about, which is 4 young males at 2 a.m. going at high speeds. And, they came through. It was a roundabout in this instance. I've just talked about how good roundabouts are, slowing people down and everything like that. They went through intentionally fast, and well, probably any other vehicles. I don't think there would have been too many around, but would have been slowing down and probably. But they left the road. They hit the power pole, and the power pole had a thing called a Raptor cushion around it. That's a Raptor. And the Raptor is not it's not connected to it. It sits around it. And it kind of does a few things. It certainly absorbs energy like a cushion, but it also rotates. And the idea is that it can rotate and redirect some of the energy. So push the vehicle away a bit. And it's about thinking, how do we manage energy as well as we can? Barrier systems are the best at it, but people thinking about this and trying other things and working out how we can manage the severity of incidents. And all those people survived, minor injuries at the worst. They're all, I assume, living healthy lives now. But certainly that incident didn't kill them, didn't leave them with lifelong debilitating injuries, even though the forensic report on it said that they hit it somewhere around 90 kilometers per hour, which is, if you think back to that video I showed you of around the 60 kilometers, it's just unbelievable that they've survived this. And the Raptor, they're just distributing energy, redirecting energy, and cushioning and absorbing energy all at once. It's certainly played the role in what is a car with very minimal safety features. So I don't think we'll do that quiz, Kathy. And there's in the notes you can download just some key mid-block points, because I think it's time to answer any questions. And Kathy, you can explain a little exercise which is all about reinforcing exposure, likelihood, and severity categorization.
Absolutely. Just a quick one before I jump in. The Raptor cushion, there's a question here from Peter saying wrong overlap. Not quite sure to what. You got that one?
Yeah. So I'm gonna have to go back and have a look at it.
Yeah. And while you're doing that, between wire rope and guardrail. Thanks, Peter.
Yeah. I don't know whether it is or not wrong overlap or not. I mean, certainly barrier systems, like a W-beam barrier system, has a certain overlap. You don't want to get that wrong because it'll spear. I have to look into Raptors whether it's the same. Good question. Yeah, so if we get into the specifics of barrier systems, we have barrier systems of varied flexibility. Now, it used to be that we would say there were three categories of barrier systems: flexible, semi-rigid, and rigid. So rigid being concrete, semi-rigid being your type B or your G4 systems, depending on where you come from, your W-beam systems, and your flexible being your wire rope or a flexible W-beam system. So the newer ones, your ram shield, easy guard style systems. The new Part 6 sort of drifts away from that because there's significant overlap between how you do it. You can tighten up post spacings and make flexible barriers more rigid and the like. So they sort of don't like to categorize like that anymore. But in terms of us thinking about it, the more flexible for a passenger vehicle we can make that barrier system, the less of the energy is transferred to the occupant of the vehicle, the better it's going to be. Now, when you're doing safe system assessments, those sort of things can factor a little bit into the severity of the crash. And you can think about that. So if you're getting a roadside and it's having a concrete barrier put down, and you know some of the crashes are going to be more severe. Now, you would be thinking about things like, well, what offset is that barrier from the edge line? Because if it's very close to the edge line, it's very hard to get enough angle on that crash, right, to get the energy transferred, because you're more likely to scrape along it, right? But if you set it off 6 meters from edge line, then there's plenty of room to yaw and to get more angle and to crash into it in some very harsh manners. So, you're sort of thinking about quite a few of these bits and pieces associated with how you end up landing on a score and whether you make a recommendation for a more flexible barrier type or not. Then you're going to think about considerations like what other road users, are there motorcyclists at risk here? Is it do we need to think about heavy vehicles breaching this barrier system and head-on crashes occurring, is it a high-risk location? Is it going to drop onto another freeway or these sorts of things? So there's quite a bit to think about in that sense. But at a high, principle level, the more flexible we can make it, the better.
With Raptors, how do we install them when the power companies and utilities say no?
Yeah. So would like to see somebody sue the utility providers.
I think you've mentioned that as an idea for us, haven't you, Ken?
Yeah. The beauty of living in Australia is the protection and pay we get when killed or seriously injured in road trauma. Like we're absolute, like the world is envious of us. Well, everybody, New Zealand does it better because it's like anything. You get injured and you're going to get, the government will look after you. Australia does it very, very extremely well. But what it means is that, people aren't, living lives with debilitating injuries from road trauma and not having any compensation associated with it. And as a result of that, there's less people suing or looking for that. Who's to blame for this? And so that's good. Like there's all good stuff about it. But what it means is that we sometimes leave these inherent problems like utility providers who all they care about is preservation of their asset. People run off the road, they hit a power pole, they're killed, multiple people killed. The utility provider's response is often to put a stronger power pole there next time because they don't want it knocked over. Like that's the way they think about it. So, and they have legislation under the, emergency acts to put whatever they want wherever they want. And yeah, I've got some frustrations there. So whoever put that in, I empathize. I used to run a utility poles working group for road safety to try to, bring this forward and get some better systems and protocols. And had some success, but it's a very challenging one. So I don't have answers to that. I hope we can get more in.
So Nicholas has found a workaround, which is they placed it around the pole, so it wasn't attached to the pole.
Yeah, anyway. Yeah, that's good. They're not attached to it, but yeah.
Sorry, and we've got a question. What is the reasoning behind them not wanting to install it?
Oh, they say ability to access, and I think somebody was also talking about potential overheating of something, which doesn't make any sense to me. I don't understand power well enough to understand that, but access to be able to, maintain up and check the pole and things. I mean, yeah.
Okay. I am going to go into the learning management system, but there's a few more comments that came in about clear zones, which was the technical basis for it being 9 metres, other than it equals 30 feet. And Queensland Streets, 1993, now we're going back, had clear zones for local and collector roads. Do you know of any barrier curb deflection studies newer than the 1970s, Ken?
No.
Okay, I'll give you some more time to think, and we'll have a look at module 2. So here's today's presentation. There's some resources we've popped in there for you. So that race safety platform, Austroads document. There's a great webinar that was done maybe a year or two ago, which shows some terrific examples from Australia and New Zealand. So that's a bit of homework for you if you haven't seen that webinar as yet. And a road design note for the compact roundabout that you also showed as well. You do have a quiz, so thank you for everyone who did their quiz last time round. There's another one, a short multiple choice style quiz, and a very short assignment, which you click into here. You will get 3 attempts at it, and it is due in 4 days and 5 hours, but it should take you like 15-20 minutes, and this is where you add your submission. So you just click on that document to open it up, and it's a fillable PDF. So what you do in the areas that are highlighted, can we all see that okay, Ken? Yep.
Yep.
Is that good? Yep. So you just fill it in. And, oh, sorry, we're looking at what you need to fill in. So the instructions are you select an intersection, anything. So it could be some that you have safety concerns about. Anthony, you sent one in earlier, so that might be one that you choose. You don't actually have to go to it. You can inspect it via Street View, or ideally it's something that you're quite familiar with. And then, as Ken mentioned, what we're looking is that you can correctly identify what is exposure, what are some factors that increase exposure, likelihood and severity. And then what are some things that you could implement to reduce each of these? So you pop in here your name, the link, so the Street View link to your particular intersection that you've chosen. So you can choose anything you'd like here. And we're not looking for a War and Peace type assignment. This is just so that we know that you have a good understanding of what is exposure, what is likelihood, what is severity. So we're looking for minimum of 1, maximum 3. So don't write any more. There's no more space for you to write any more in there. Factors that influence exposure. Same for likelihood, and then severity, and then just one change that you could make, and there's no limit here. One change that you could make to reduce the impact of exposure, likelihood, and severity. Save that and then submit. Hold on. Oopsies. Yeah. And then we might get someone to run through theirs as an example at the start of next session. And we won't be seeing Ken and his marvelous moustache there. We'll be seeing Max and probably his marvelous moustache instead. No questions? Are we all good? No, we've got questions. What have we got? Okay, no. I think we're good. So do your quiz, do the assignment, and we'll see you next Tuesday.
Yep, and like always, get in contact if you are struggling or you're a bit confused. Shoot Kathy an email, and yeah, we'll go from there.
Terrific. Thank you, Ken. Thanks, everybody.
Bye.
Great day. See ya.